What's going on, everybody? This is the walkthrough for Color of Light 1.4, 1.5, 1.6. So we start off with a small McGraw-Hill reading, and then we have a few questions about different wavelengths and why they travel at different speeds. Why does violet refract the most? And which color refracts the least? And then blue or yellow, which refracts more? So as we get into the reading, why do different colors refract differently? It's because waves with longer wavelengths and higher frequencies, they travel at greater speeds. And why does violet refract the most? And we see that violet refracts the most because its frequencies are the highest. Red has the lowest and refracts the least. So which color refracts the least? It's going to be red. Which color refracts the most? It's going to be violet. And does blue or yellow refract more? Well, the higher the frequency we have, the more it refracts. So this is the least to the most. So between yellow and blue, we're going to see blue refracting more. In the next section, we're going to be looking at rainbows. And when we look at the image of rainbows, we can see that white light enters, and what they actually do is they actually go inside of each droplet and they bend the light at different angles. So each wavelength of light refracts as it enters the droplet and reflects back into the droplet, and it moves again when it leaves. So again, the refraction occurs when it enters, it bounces off different parts of the droplet, and as it exits, it spreads. And in the 1.6 section, we have a series of questions about eyesight. Where does the image form in your eye? What are the rods and cones used for? How color is seen in dim light? And how many different types of cones are found in the retina? So as we read through this section, we see that light enters the eye and is reflected through the cornea at the back of your eye. What are rod cells used for? Rod cells are sensitive to low light levels. So rod cells are used to be able to see in the dark. What are cone cells used for? Looking at cone cells, which are magnified here to be almost kind of like a purple color, cones enable a person to see color. And following that, in very dim light, only rod cells function. So at night, you're really not able to see color. So to address this next question, explain how color is seen in dim light. Color is not able to be seen in dim light. You cannot see color in dim light. You can basically only see like shapes and maybe different types of light. And how many different types of cone cells are found in the retina? Going to the source material, the retina has 3 types of cone cells. And while there are a lot of different types of cone cells in there, there's only 3 different types. So make sure you jot down all these answers. If you're having difficulty writing this down, make sure you pause the video, and all the answers have been highlighted for your convenience. Thanks a lot. Keep working. Get that A.